Hi everyone, this is your first video for 6-1. We're talking about exponential functions. You have a definition here. An exponential function is a function of the form y equals a times b to the power of x. We're going to look at two different things today. The first one's growth, the second is decay. For both of these, you're going to use that general equation, y equals a times b to the power of x. Now, I know something is an exponential growth equation when my b value is greater than 1. So it could be 2, it could be 3, it could be 4, it could be 2.5, it could be 7.6, whatever. And then I know it's exponential decay when b is between 0 and 1. So essentially it's a fraction or a decimal, but it can't be bigger than 1. So you could have 1/2, you could have 0.5, you could have 0.75, but you can't have anything like 1.25 or 1.5. Those wouldn't work. We're going to look at our first two graphs and equations. My first one is f of x equals 2 to the power of x. Now, this one wants me to identify my a value and my b value. Remember my functions of that form that's over here, y equals a times b to the power of x. So really we're doing a times b to the power of x. Your b value is always a thing being raised to the power of x. So in this case, my b value is 2. A should be the number being multiplied in front of it. Now, right now, notice there isn't a number in front of it. So technically, this is the same as 1 times 2 to the power of x. So my a value for this is going to be 1. Now we need to figure out if it's a growth or decay function. So remember, when you look at your b value, if that value is bigger than 1, then it's going to be growth. If that number is between 0 and 1, it's going to be decay. So in this case, we have 2, which is bigger than 1. So this one is going to be growth. Another way you could tell is if you look at your graph, and if you travel from left to right. If I go from left to right, notice that I start down here, and then my graph goes up, 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 forever and ever and ever. So that means that one is going to grow. We start at the bottom, it's getting bigger and bigger and bigger. So it is a growth function. All right, let's look at your second example. For this one, we have g of x equals 5 times 1/2 x, or excuse me, g of x equals 5 to the times 1/2 to the power of x. Again, we need to figure out our a and b values. Remember, a is going to be your number outside of the parentheses. Ooh, that's not a highlighter. Awkward. So it's going to be 5. Ooh, and that is a highlighter. Your b value is going to be the number raised to the power of x. In our case, it's 1/2. Again, remember, when we're trying to decide growth or decay, we're looking at our b value. In this case, my b value is 1/2. So that definitely is not greater than 1, so it can't be a growth function. That is a number between 0 and 1, so it is going to be decay. Again, remember, when you're looking at this, if b is a fraction or a decimal that is smaller than 1, then it will be decay. You can also tell this from the graph. If I travel from left to right again, I start way at the top here, and then it goes down, 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 down. So when I think of decay, I think of something getting smaller. As I move from left to right, my graph gets closer and closer to that 0 line. It's going down, so it is in fact going to be a decay function. All right, thank you for watching these videos. Go ahead and watch the next one and work on your interactive notebook. As always, if you have any questions, don't hesitate to reach out to your teacher.